Hi guys, hope all of us are doing great. My name is Ernest and this is Ernest Sciences and Mathematics TV channel. Today we are going to look at a concept under the concept of thermodynamics, and that is the concept of work that is done in the process of expansion or compression. And in this specific case, we are going to look at a specific part of matter which we refer to as gases. And in our subsequent videos also we are going to look at different aspects that we are, of course, not going to concentrate on this specific discussion. So therefore, this is going to be, of course, a description of the concept of a work insofar as expansion and compression of a gas is concerned. And in our first video, we had mentioned that in changing from one state to another, a system can be able to perform what we refer to as a work, and we had given work in terms of W. So therefore, we are going to use this specific initial in this particular discussion in reference to the concept of work. And we see that if a system does work, we're going to give this W in terms of positive. So this basically refers to as the state when the system does work. And when work is done on the system, then therefore the value for W is going to be negative. So this implies that work is done on the system. Hope my handwriting is legible. So in this particular case, we're going to use these two different scenarios in trying to describe the concept of compression and expansion, which is a discussion for today, respectively. Now, in this case, I had mentioned that for and given a reference for a chemical reaction, which is, of course, changing from a state A to B. And we had said that when a system changes from a state, for instance, A to B, then therefore we're going to see that its internal energy, which we had referred to as E, is going to change by delta E, which we had given as E2 minus E1 for a general case. And we had mentioned that for a change from A to B, then therefore it's going to be the energy of the product minus the energy of the reactants given as such. So in this particular case, there's going to be a accompaniment of energy. And we had mentioned, of course, that there are some specific variables that we're going to consider whenever we're trying to talk about the universal energy of a system. And we had said that the universal energy of a system is going to depend on a number of variables. And the first one we had mentioned was pressure, volume, temperature, mass, and the composition of that specific system. So therefore, we are going to consider in this specific discussion the concept of pressure, perhaps volume and temperature, using this specific illustration for figure A, which I'm going to mention shortly in this specific discussion. So we are going to consider the concept of a chamber that consists of a gas, and this gas is going to undergo compression, and the difference from, let's say this is a point M, N, and O. So the difference between M, O is the total volume of the initial volume of the gas. And when this pressure is applied on this specific surface, then therefore the gas is compressed between M, N, which depicts a height of H. So this is going to be the height H, and the volume of the chamber that is affected, then therefore is going to be entailing the concept of a change in volume. So therefore the new volume will be encompassed between the height of N and O given as such. So we can be able to describe this specific aspect of a change insofar as pressure, volume, and temperature is concerned, whereby we had said that from the first law of thermodynamics, we had said that we can be able to describe the heat that is involved in a change, whereby the heat is going to be, or rather if we said that when a system is going to change from the state A to B, this is going to encompass internal energy, which we said which is going to change by delta E. And of course, we're going to see that the system is going to perform some work which we have given an initial W, and some amount of heat is going to be, of course, absorbed. So in this case, then therefore this goes, or rather refers to the concept of this specific heat which is being absorbed or involved in this particular change. Part of it is used to change this internal energy, and part of it is going to be used to do work. Of course, this is going to be a derivation of the first law of thermodynamics that we had said. So therefore, we can be able to describe the change in internal energy using this specific equation, which is Q minus W, where Q is heat and W is work given as such. Now in our subsequent videos, we're going to see that we can be able to describe a small change or an infinitesimal change in this specific concept of energy by using a differential or the derivative dE, of course, which is going to be a differential given as the change in Q minus the change in W, which is going to be an infinitesimal change in this specific change in internal energy which I've given. So therefore, we can be able to give this specific variation using equation 1 or 2, where 2 constitutes the infinitesimal change in this internal energy. Of course, then therefore we can be able to consider our case which I've given on the right side of the board. And of course, where we had said that if pressure is applied in this specific cylinder, then therefore we're going to see that the volume of this specific cylinder is going to change by H. And we can be able to describe the external work that was involved in this particular case from the normal concept of work that we said. And we said that work can be described as the product of force applied times the distance covered. And in this particular case, we have said that we can be able to find a force as a derivative of the pressure which is applied in this specific chamber, of course, of area A. So therefore, we say that pressure is a ratio between force and the area which is going to be applied. Therefore, we can be able to describe force as a product of pressure and area given as such. So if we try to look at this, we're going to see that we can be able to describe area given as such, and of course the change in of course this specific case is going to be entailing the change in volume, and we can be able to give that one in terms of the external work which was done in this particular system, whereby work is going to entail the force which is a product of pressure times the area times the distance covered. In this particular case is going to be the height. But from a normal geometrical or solving of the equations of specifically regular figures, we are going to see that the area times the height is going to encompass this specific change in volume that is going to be given as such. So therefore, we can be able to describe our work in this particular case using the product of pressure. And this is going to be external pressure times the change in volume given as such. So therefore, this is going to constitute what we refer to as the work that is going to be done in the process of either expansion or compression of this specific gas substrate. So if we perform a reverse process, of course, we're going to see that the change in pressure and volume, if we try to describe the magnitude of work that is going to be done, can be generally given using that specific equation. So therefore, in our next discussion, we're going to look at specific examples which are going to deal with perhaps evaluation of either a work done, the pressure applied, or the force applied in this specific scenario for either expansion or compression, and that is going to give us a way of trying to quantify various aspects for pressure, temperature, and volume which are involved in this particular case for the work done in these two processes. So that is it for now, guys. Kindly check our description boxes for related links of other videos which are going to be, of course, dealing with the same topic. So that is it for now, guys. Bye, God bless.